and welcome to Chapter 2, Section 2. We are dealing with more quantitative data today, but I just want to show you two more graphs that we can make with them. So last time we talked about quantitative data and 4 different graphs. So the frequency histogram, the relative frequency histogram, the frequency polygon, and the ogive. So today I just want to add 2 more. They're a little bit easier, in my opinion, the Stemplots and the Dotplots. So 2 more graphs that deal with quantitative data, and then we'll move on to qualitative data and paired data. So I want to start with an example. So in a study of how far students commute to school, a random sample of 20 high school students were asked how many miles they traveled one way to school, and here is their data right here. So in a Stemplot, we want to make basically a graph where we have 2 columns in a table, a stem and a leaf column. In order to do this, it makes it a lot easier if we put all our data in order first. So I'm going to do this in the calculator, just because our calculator can put things in order really easily. So just as a reminder, we're going into Stat and then Edit to list our numbers out. So I'm going to type in all my numbers, 5.6, enter, 2.4, enter, 5.1, enter, and I'm going to continue on. So I've got all my data in the calculator. I'm on the 21st spot that's empty, so that means I have 20 data points in my list. I'm gonna go back into the home screen, so second mode, and then second stat. Go over to Ops, Sort A to put everything in order. So I need to type in my list 1 because that's where I typed in all my data. So second, number 1, and my parentheses, and then enter. Now it says it's done. So if I go back into my list now, so stat enter, everything's in order from smallest to biggest. So remember, sort A is sort ascending by smallest to biggest. If you choose the other one, it goes from biggest to smallest. Okay, so we have everything in order. To make our stem plot, we're basically going to be splitting up each data point into a stem and a leaf portion of the number itself. So like, let's say if we were to look at our first number of 5.6, the last digit in the number for us would be the 6, is always going to be the leaf. So no matter what your number set looks like, the last digit is always the leaf, which makes everything else the stem. And we'll do more examples where we have different types of numbers so you can see how this is going to look like in, let's say, another set of data. So for all of our data points, the first decimal place, so everything after the decimal, will be the leaf, and then the whole number part will be the stem. So looking at my ordered data set, I have 0.2 as my first number, which means that's a stem of 0 and a leaf of 2. Even though in my calculator the 0 isn't there, we technically know 0.2 is the same as 0.2. Then the second number is 0.5 in the data set. So that means it has a stem of 0. So once I've already put the stem here, I don't need to put it again. The leaf, though, this time is going to be 5. And then we have 0.7. So again, I have a stem of 0, a leaf of 7. And then for the fourth number in the data set, it was 0.8. So stem of 0, leaf of 8. Then the next number I have after that is a 2. So our stems, they have to go in order. So if I have a stem of 0 is where I started, then the next number after 0 would be 1. So I have to write a 1 next, then a 2, and so on. However, in my stem of 1, I don't have any numbers because the next number in my data set is a 2, which is really the same as 2.0. And that's what I had in my data set as well, 2.0 there. So I'm going to skip the stem of 1, put nothing in there, but you have to leave the stem of 1 on the left side here. You can't skip that number. You just wouldn't have anything in that row. Then I'm going to continue on. So after the 2 was a 2.2, and then a 2.3, and if I scroll down, after 2.3 is a 2.4, and then a 2.8, and then a 2.9. You'll also notice that as I write my leaves, I kind of want them to line up so it's easier for me to count how many are in each row. So it kind of keeps it organized that way. And let's keep going. So after the 2.9, there is a 3. So that would be 3.0, 3.1, 3.5. And continuing on, I have 3.8. And then I move down into 4.1. So that's the next stem of 4.1, 4.7, 4.9. And then there's another 4.9. So I'm just going to list that 9 twice. And then my next number after that is a 5.1, so I gotta add one more stem. So a stem of 5, leaf of 1, oops, and then 5.6 was my last and biggest number. So this is it. This is the stem plot. So the last thing we want to do when we make a stem plot is to actually add a key. We want to make sure people know that our numbers in our data set, we're all decimals, so that they read our stem plot not as like whole numbers, but to make sure that they know what our numbers actually stand for. So we're going to just choose one of our numbers from our data set. So I'll choose the 0.2 just because it's the first one, but it doesn't matter. And I'm just going to write it as 0 and then a solid line or vertical line, and then the 2 just kind of stand for the column line that kind of split up our stem and our leaves, and then that stands for 0.2 miles as the distance from their school, which is pretty close. That's a very short distance for living between your home and your school. So every time we make a stem plot, we want to include that key, and it doesn't matter what number you use as long as you put something there from your data set. So this time I wanted to do a data set where we have 3-digit numbers. So as you can see, it's a sample of 14-year-olds from the United Kingdom. We're randomly selected. Here are the heights of the students in centimeters, because, you know, everywhere else uses the metric system instead of, you know, inches and feet. So here, all of our data is 3 digits long. So in order to make our stem and leaf plot, the last digit of each data point is going to be the leaf. Meaning, like if we had this 151, the last digit would be the 1 right there, and that would be the leaf, which means the 15 would be the stem, because that's like everything else in the number other than the leaf. And I've already put our data in order for us between male and female because I want to compare later. So I'm just going to make a stem plot of the male heights first. So with my male heights, the first stem I'm going to have, because our smallest number is 151, will be a stem of 15 with a leaf of 1. The second number is 154, so a stem of 15 and a leaf of 4. 157, 159, and then we go into a stem of 16 for the 162, 163, 165, another 165, 167, 169, and then our next number is 174, so that's a stem of 17, 174, 175, 176, 177, and then 180, so that's a stem of 18 with a 0 after for the leaf, 183, 187. So that would be the stem and leaf plot of all the male heights. And of course, we're going to include our key. So again, I'm just going to pick the first number that I had, which was a stem of 15 and a leaf of 1. This would stand for 151 centimeters in height. So the reason why I wanted to include both the male and female data set is because I also want to make a back-to-back stem plot. So it's still a stem plot, but as from the name it says back-to-back, so it's going to be comparing 2 sets of data at the same time. So when we make our stem and leaf plot, we're going to have the stem in the middle this time, and then leaves on the left and the right. So as you can see, I've got my stem in the middle. The leaf, I'm going to label at the top which category the data comes from. So on the right side, I'm going to put all my male data. On the left side, I'm going to put all the female data. And so with my male data, this is going to look exactly like the stem and leaf plot that I made before. So I'm just going to copy that over, and then we'll deal with the female data. So with my female data, again, I have everything in order for you already. So our smallest number is 152. So it has a stem of 15 and a leaf of 2. When I start writing down my numbers, I always start from the middle and then it'll get bigger outwards. So my next number is the 153. So that'll go to the left this time. Another 153, a 157, 158, 158, and 159. Ran out of space. And then we move on to the 160s. So we have 160, 160, 161. Okay, so I moved my whole graph over so I have more space. I'm on 163, the second one, and then 164, 165, 165, 166, and I guess I still need more space than that. So I've got the two 166s, 167, 168, 168, 169. Okay, so as you can see, we've got a lot more numbers for the females that's in the 160s, because this whole entire row has a stem of 16 and then these are the leaves. So all of our numbers here, like the maximum for a female is 169 centimeters tall, which makes sense because guys tend to be generally taller than girls, and so that's why they had like a much bigger range of numbers for the male heights versus the female heights. But that's kind of the nice part about a back-to-back stem plot is you can compare two different categories here. So we're dealing with quantitative data from two separate data sets, the males and the females, and then we get to compare them together in a back-to-back stem plot. The last type of graph I want to make today is called the dot plot. So for this example, I'm going to reuse the female heights data set that I had from before. And in a dot plot, basically, there's going to be a bunch of dots in it. That's why it's called a dot plot. So in order to make this graph, we want to first set up a horizontal axis. So I'm just going to draw a horizontal line. We're going to label this as the x-axis, or for us, we are talking about female heights in centimeters. Oh, I totally forgot to leave a key for my last data set. So in a back-to-back stem plot, for the key, you just want to list out both and label which one it is. Okay, so with my dot plot, back to my dot plot, we are labeling our horizontal axis as female heights, and our smallest number is 152, so that's where I'm going to start. But then, in a dot plot, your increments on the x-axis, you always have to go by the same amount every time. So since all of our numbers in our data set are whole numbers, then I have to go by ones. So I'm going to go from 152 to 153, 154, and this keeps going all the way until my biggest number, which was 169. So just like how in a stem plot you can't skip any stems, here we can't skip any numbers when we go by ones in a dot plot. So once we have our x-axis set up, then we're just going to go ahead and make dots above every number where we have a data point. So I'm going to start with the 152 because that was my first data point, and on 152 I'm just going to place a dot there. Then I have 153, another dot there, another 153, so I put a second dot on top of 153. Then my next data point was 157, so I skipped down to 157, put a dot. 158 occurs 3 times, so that means I'm going to have 3 dots on 158. Then 159 I have a dot. There are 2 160s, so 2 dots above 160, 161, 2 dots above 163, 164, 2 dots above 165, and 2 dots above 166, 167, 168, there's 2 of them, and then 169 was our last number. So that's our dot plot right there. Pretty simple to make, nothing crazy, as long as you remember to label everything. So label your x-axis with what your numbers stand for, label your increments on the graph itself. So what's nice about the stem plots and the dot plots compared to the graphs that we did last time. Last time we made a bunch of histograms or the line graphs with the ogive and the polygon, but in the stem plot and the dot plot, what's nice about them is when you look at the graphs themselves, you can actually see what each of the individual data points are. Because with the histograms, you just have the bars, and so you can see like how many there are within that bar, but you don't know the numbers themselves, because you just know within that bar, this is like, there's 7 data points that are between this number and this number with your class limits, but you don't actually know what the actual numbers are individually. But in a stem plot and a dot plot, you can actually see what each of the numbers are going to be within your data set. So that's kind of nice and a little bit easier to use sometimes. But that's it for this section. Thanks for watching. Bye.